Okay. All right. So yeah, I am here to talk about how to control your dependencies and not let them control you. Um, and we're going to be showing what dependencies are, why they're so problematic, and then yeah, how to wrangle them in. So if you don't know, my name is Brandon. Here's some contact info, and I put Steven's info here. He's my close collaborator. Everything I'm talking about today is things that we worked on together. So if you have any questions, you can ask me, you can ask him, ask either one of us. And if you didn't know, we run a site called Point Free where we talk about things like this and a whole bunch of other kinds of things. So if you find this interesting, I encourage you to check it out. But let's really start with the core of it, which is this seemingly simple question, which is what is a dependency? And it's kind of surprisingly tricky to get right. And I can't claim to have the most universal definition out there for it, but for the purposes of this talk, it will be the types and functions in your application that need to interact with outside systems that you do not control. Now, it's a little bit nebulous, so let's just look at a whole bunch of examples so that we can get some intuition. Perhaps the most canonical example is network clients. So if you've got this little API client in your code that under the hood is probably using URL session or something like that, and somewhere in your code you use this API, you are interacting with an external system, not only because you're making a network request, but then that network request is going out to some server, and you most likely do not control that server, especially if you're hitting things like a Mastodon API or a Stripe API, and even if you're hitting your own server, it's still an external system that you probably don't personally work on that. There's probably a backend team, and you're forming some kind of dependency on that external system. But then also, even touching some of Apple's code is a dependency. You don't bring this in via SPM or anything like that, but if you are using core location, the act of reaching out to this location manager, requesting access or authorization to get location, and then getting that location, you're interacting with the GPS antenna on the device, you're interacting with satellites orbiting the Earth. This is a massive external system that you do not control, and so this is a dependency. And then also just the file system. If you used either date contents of or data contents of or data.write, you are interacting with a file system on the device, which is this massive global blob of mutable data that anybody can write to, anyone can read to. You have no control over that. And so this is a massive dependency. And also that extends to even user defaults. User default seems a little bit more innocent, but also, again, it's just this massive blob of mutable data out there. And then also, of course, this is just literally a third-party dependency that you probably add via SPM or something, but things like Firebase, massive dependency. And this is even, in some sense, kind of a mega dependency because for whatever reason, Firebase also handles things like, what does it do? It does network requests, it handles analytics, crash reporting, logging, remote config, authentication, push notifications, storage, and more. This thing touches every possible external system you could imagine. And of course, all that stuff is controlled by Google, not you. And then things like even just task.sleep. If you've ever used this in your code, or even dispatch-queue.main.schedule or .async, again, it's an external system. You don't have control over time. When you say task.sleep, you've got no choice but to just sit there and wait for time to pass before those things unsuspend. And then even seemingly innocuous things such as the date and UUID initializers, they are dependencies. They reach out into an external system to compute the current date or some random UUID, and you don't control those systems. So, and there's a lot more examples. Your code is most likely littered with dependencies. And so, if you believe everything I've said so far, then you may, it would seem like dependencies are just seemingly ubiquitous. But if this is the first time you're hearing about dependencies or thinking about dependencies, you may wonder what the big deal is. You've probably been coding for years, apparently sprinkling dependencies throughout all your code, and you've probably had no trouble as far as you know, and you just think that this is maybe not even worth your time. But the point of this talk, and I'm here to tell you, that it absolutely is worth thinking about these things because they cause a lot of problems in code. And you've probably come up with all types of little workarounds and fun little things you personally can do to work around these problems, but it actually just permeates every aspect of your code. And so let's go through those problems. The first and the most obvious one is usually when you bring in a third-party dependency, it just increases your build time. So Firebase, just a clean Scratch project with nothing but Firebase, you're compiling for over 80 seconds just for Firebase. And that's on an M1. I'm pretty sure I took that on an M1. So that means every time you clean the project or you switch branches or you make a significant change to your project, you may be incurring that cost. Or also CI, you're incurring that cost. Now, that doesn't apply to Apple's frameworks, of course. Like all that kind of ambiently comes for free. This is really only for third-party dependencies that are not Apple. Another problem is that it can make your code very annoying to run. And I have a demo for this. Because they reach out to these uncontrolled systems, you're often just at the mercy of those systems to run your code in the way you want to run it. And so I'm going to switch to an Xcode project, this one here. And I have something in this project. I had a whole bunch of demos, but for this one, it's called Countdown. Let's run the simulator. I won't have to boot one from scratch. Okay. And we'll go to the Countdown demo. And all it does is it counts down from 10, but we had to wait for 10 seconds. So let's wait. Wait for it. Wait for it. All right, some confetti. Fantastic stuff. But I don't know if you noticed, but actually the confetti was behind the number, and I kind of wish the confetti was on top of the number. And if I look at that code, I see very reasonable SwiftUI code, seemingly reasonable SwiftUI code. And it's kind of obvious what the problem is. It's that this if statement is where the confetti is happening. It is behind in the Z stack. So I got to move it down. I got to run the simulator. I got to drill down. I got to find the feature, and I can wait 10 more seconds. All right. I think you can imagine what's going to happen. I'm not going to do that. And the thing that's supposed to fix all this is SwiftUI previews. So I'm going to load up into SwiftUI preview because that's supposed to give you that fast iteration cycle. We should be able to do, everything in SwiftUI previews. If it loads. Okay. But SwiftUI Preview, of course, doesn't help with this. We still have to wait 10 seconds. There's nothing special about SwiftUI Preview that's going to just fast forward this. And so now, if I'm patient enough and I wait, I do see that the confetti is on top. Cool. But that was kind of a pain, right? We are forced to wait for real-world time to see the thing that we want to see. It is not immediate. We are dependent on this external system. Yeah, we just got no choice but to wait for real-world time to pass by. And I just have to hope that while I'm waiting, I don't get distracted by a colleague or start reading the news or doing something. I'm going to be very focused for those 10 seconds. So we are seeing in very concrete terms what it means for a dependency to kind of control you rather than you controlling it. It has dictated the way I work on this feature. All right, go back to slides. All right. Another problem is that some of them just don't even work in SwiftUI preview. So that dependency made the preview annoying to work, but some just don't work in previews. And I got another example for that. So go to the simulator, and I've got a fun little location demo here, and it's going to put me in, oh, I need Wi-Fi. Didn't think about that. There's a public. Hopefully it doesn't pop up something at me. Okay. So then I'm going to rerun the simulator. All right. So picture, if you will, a map of Toronto. And I tap this button, and I allow location, or allow exact location, and then it'll zoom us in right into TIFF. I hope you can imagine this. And this is a very reasonable thing to do, and the code is extremely reasonable. I've got, even publishing on a background thread. I've got, I think that's just a map kit problem. Ignore the purple warning. So I've got my little observable object. It manages a little location manager on the inside. I got the coordinate region that's going to drive where we're zoomed in on the map. And I've got some methods that we call when the location button is tapped, a request authorization or request location. This is all very reasonable code. But what's not so reasonable, and this isn't going to really translate well since the map is not loading. Well, all right, so imagine, if you will, more that now we're focused in on Toronto. I tap this button. Oh, all right. We are having a real moment here because I'm also using the Xcode beta, and now this is new. So this is good. This is now showing that you do get access to that little alert. That's new in the beta, so we're going to really be improvising this. So what would have happened in pre-beta is that this preview is just broken. You tap this button and nothing happens at all. And now it looks like they're starting to seed in some of the authorization stuff into preview. So that's great. So this would have been an example showing how the dependency on location manager is controlling us. Oh, hey, look, there we are. Okay, maybe it's just slow internet. And I guess if I go here and then hit this, it zooms me back. Oh, I'm in Apple. Okay. All right, so location manager, it's a dependency. I don't think I need to convince you of that. Let's move on, and we'll see how this rolls. Let's go back to our presentation. So let's go to the example of some dependencies don't just make working in previews annoying like the location manager used to and maybe doesn't as much anymore, but some just completely break the preview. Just make it so that your preview just does not work whatsoever. Let's see what happens with this one. I'm going to go back to our demo, and I've got a demo that does not use internet, that when you drill down to it, it asks you for access to the contacts, you grant it, and it shows the contacts from the device. And the code for this is completely reasonable. It has some local state for some users on a peer. It interacts with Apple APIs to load up some users and then slaps them into the @state, and it shows in SwiftUI. Completely reasonable. But when you run it in the preview, all right, nothing shows. And I mean, I think that's, maybe you could understand why that would be. I mean, certainly the preview probably doesn't have any contacts. Maybe that's not that big of a deal. What is a big deal, though, is I've got a little package here, because as we've learned in Terry's talk, it is increasingly popular to modularize code bases and put features into SPM packages, and you would want a preview. But that code, that seemingly reasonable code, completely crashes the preview. I just am not allowed to run this code whatsoever. It just completely crashes. And the reason it crashes is that secretly you need this little info.plist in order to describe why you're asking for contacts. And SPM packages have no concept of an info plist. And so the moment I brought this code out and we access a contact API, it just crashes the preview. So this is, of course, an example of the dependency controlling us. We've just now ruined our ability to work on this feature because we're just kind of reaching out to APIs that we don't control willy-nilly. All right, so that's a bad thing. That's a very bad thing. All right, let's go back. All right, more problems. Often, if you just kind of you just access dependencies without regard, you will accidentally interact with live dependencies in situations that you don't expect and can be kind of harmful. And I've got a demo for this. I'm going to run the simulator again. All right, I've got this analytics demo, and it's basically the location demo. Oh, there's New York. It's basically the location demo, but secretly, behind the scenes, we are tracking analytics. So allow once. Let me search analytics. So secretly, as I'm doing various things in this UI, I'm tracking analytics, sorry, and you would want to track analytics to get insight into what your users are doing in your app. That's completely reasonable. What is not reasonable, though, is that when I go to this feature in the preview and run it in the preview, I'll bring up the logs, and I'll switch over to the preview logs, we're also tracking analytics in the previews. And so in the course of an afternoon while working on this feature, I've inadvertently tracked hundreds or thousands of events to a live analytics data store and completely ruined all the data. Made it impossible to make a business decision because I am just reaching out to this analytics client without regard, and that seems pretty problematic. And you may not even know you're doing that unless you were studiously looking at your logs and trying to understand what's going on. And you may be making business decisions saying, people really love this feature just because you happen to be working on it for weeks, just reloading it over and over and over. And so that seems really bad. And the code, I didn't go through the code, but it's exactly what the location demo was, except now we've got this analytics client with this singleton instance that does a little URL session under the hood, and then we print to the console. And we just kind of littered it throughout. We're doing analytics client.shared.track for every little thing that we're interested in. So seemingly reasonable code that leads to a very dangerous situation. All right. So that's another problem with dependencies. And then there's more problems. And that is, and I put this last, this is one of the things that I'm most interested in, but I just don't think testing is a huge topic in the iOS community. And I wish it was, so I put this slide last. But uncontrolled dependencies make it very difficult to unit test or even UI test applications. And I've got a demo for this too. All right, but what I've got is an application called the Scrumdinger, which is some Apple source code from a couple years ago that is actually surprisingly really interesting. I find it a lot more interesting than the Fruta and the food truck and all those demos. This has some real interesting patterns in it of like real problems that you have to solve in a real app. It deals with a speech recognizer. It deals with very complex navigation flows. It deals with persistence. It's got a lot of good elements in it. And it's built in a way that does not think about testing whatsoever. It does not care about controlling dependencies. And that's totally fine because its main point is to give a complex code base to millions of developers to get them interested in these APIs. I completely understand why it's built the way it is. But one of the cool things about UI testing is that no matter how your app is built, you always have the ability to write a UI test because it's just literally loading it up in the simulator, simulating tapping around on the screen, and you just assert what is displayed on the screen after. So it doesn't matter what your app is doing. Usually you can write a UI test. And so I wrote one for this app, completely unchanged. I'm going to run it, and I'll describe what the test is doing as it's running. All right, so what the test does is launches the app, it adds a scrum, it types in some stuff, adds some attendees, hits add, and then it exits and relaunches from scratch and then asserts that the meeting that was added from the previous time is still there. And that test passed just fine. However, I'm going to run it again just to have some fun. It's going to go through all those steps again. Does anyone know what's going to happen? All right, it failed this time because I had an assertion that when we finished adding that scrum, there was one cell, and that cell had the text engineering, which was the thing added previously. And the reason this fails is because on the second run, the persistence from the first run bled over into the later test. And that's because this application has just unfettered access to the disk. It writes data to it without abandon, and then later runs of the app are reading that data, and it's infecting this test. And so I have no choice but to slightly weaken it and say that it's not that there's one row in the list, but there's at least one row. And I would have to do the same here. And then if there was ever a day that I actually introduced a bug that maybe added 2 rows when I only meant to add 1, this test would pass even though there was a bug. So we have no choice but to weaken our assertions because of this uncontrolled dependency. Okay, so what we're seeing here, like over and over, is that seemingly reasonable code can lead to some very unfortunate results. And everyone here has probably encountered some version of one of these problems. Like maybe it's a preview that doesn't work great, so you run the simulator. Or maybe the simulator doesn't work great because you're accessing some advanced dependency like the motion on like the gyroscope doesn't work on the simulator, so then you're forced to run it on the actual device. And you may have just kind of learned to live with all those problems, and maybe you've got your own little bag of tricks to get through the day, to work around those problems, but that doesn't really scale well when you're on a team. Even if it's just one other colleague or an entire team of colleagues, you now have to deploy that bag of tricks to everybody. And everybody's got to know the mental model for kind of dodging these mines, this minefield of a code base, because of these dependencies just touching anything they want to touch. All right? And so what I'm trying to say overall is that just working in a code base with lots of uncontrolled dependencies can be incredibly annoying, and so we should try to do something about it. And so, all right, that was a lot of time spent on negativity, and so now let's focus on some positivity. Let's actually do something about this. What can we do to fix this problem of dependencies? And in short, just don't reach out to code that you don't control. And that includes network clients, or rather URL session, making network requests, third-party APIs, including Apple's frameworks such as Core Location, also things like clocks and data initializers and UI initializers, all that stuff. Those are all external systems, and you shouldn't touch that code directly in your code if you want to be able to control the environment your feature executes in and not be susceptible to the vagaries of the outside world. So let's see what that looks like in a few concrete cases. You've got this. This was in the countdown feature. We had a little timer to count down from 10 down to 1. Don't reach out for task.sleep. Instead, use something like clock.sleep. Now, and let's see, we've got that in Xcode. All right, so here is our old demo that wasn't great, but then we've got a version of all those demos that are controlled. And here in the countdown, the only change I've made is rather than reaching out to task.sleep down in this kind of on-appear view modifier, I am passing in an explicit clock to say this is the notion of sleeping I want you to use. And typically it'll be the real one, the one that waits for real time, but you can substitute other versions in. And then we use that clock to sleep rather than doing task.sleep. All right, and what that means, I don't know if you noticed just a moment ago, when I ran the preview, I have the timer definitely at 10, yet we're not waiting for 10 seconds. It counts down just like really immediately. I can run it over and over. And the reason it's doing that is because I've decided that in this preview, I want to use something called an immediate clock. And that is a clock that just ignores you. When you tell it to sleep, it just ignores you and lets execution continue right on. All right, and the only reason we get to do this is because we controlled the dependency on time by providing an explicit clock. We didn't just reach out to task.sleep. All right, now this immediate clock isn't something you get from Apple, unfortunately. You got to make it yourself, or we have a library that does it. But that's not the point. The point is you got to control the dependency, and then you get to completely change the execution environment that your feature runs in. All right, so that's our first example of controlling a dependency. You just provide the dependency to the feature, and that allows you to swap in different versions of the dependency at runtime. Okay. The next one we looked at, well, it wasn't the next one, it was actually the last one, but the next one that makes narratively sense, the most sense right now, is analytics. All right, because this requires just a little bit more work to control. We were very lucky a moment ago that the clock protocol is just something that's provided to us from Apple. We didn't have to do any other work. But for analytics, we got to do a little bit of work to kind of provide that abstraction around the concept of analytics. All right, so the fix to our analytics problems, I go back to Xcode. Is we got to put an abstraction in front of the analytics rather than just having this singleton that we're just allowed to freely reach out to, grab, and then track events with. All right, now if you know any of the work that Steve and I do, you will know that we do not reach for protocols for this kind of abstraction, but that's besides the point. Use whatever tool you want, whether it's a protocol or a struct with some closures, whatever, that isn't the important part. The important part is to put an interface in front of this dependency that you do not control so that you can take control back over it. And so with this protocol, we provide an analytics client to the feature, And that allows, and then we use it, rather than reaching out to that singleton, we use it, and that allows us to do something where in the preview, we will provide an explicit analytics client that is a no-op analytics client. And that's one that does not do any URL session, does not interact with a analytics data store out on our servers. It just prints to the console that we skip this analytics event and you're good. Whereas the live analytics actually does do that work. And so now when we run this and we look at the logs, oh, and preview, thanks. Now when I refresh this over and over and over, these are all skipped analytics. We don't have to worry about muddying up the data on our servers. All right, so we've taken control over this analytics client, and we don't have to be afraid of accidentally tracking real data out on our server and messing up our business decisions. Okay. All right, so that's a good example. Let's go to a more advanced example. And because those two examples may lead you to believe that it's always so easy to control dependencies, but that is not the case. The more complicated the dependency, the more complicated it is to control. So let's look at that Apple framework, the core location one, the location manager. What does it take to kind of control that so that we don't have to, well, I mean, this isn't going to really connect anymore because the preview does a lot more than it used to, but let's use our imagination. So I'm going to go back to Xcode, and what we did, actually, this might work still. So what we did is we put an interface in front of the idea of the location manager or interacting with the location APIs. And there were 4 fundamental things we could do. We can get the current authorization status, because that can help us decide what do we want to do in the UI, whether they've denied before or we've never asked before. And then we want to be able to ask for authorization from the user. We want to request their current location. And then location managers work with the delegate system. And so our interface will allow us to subscribe to just a stream of delegate events. And this would be an enum with just all the various delegate methods that we're interested in, such as when their authorization changes, when something fails, or when we do actually get their locations. And so we start using this client, we provide it explicitly, and we start using it rather than calling out to CL Location Manager directly. And the reason we do that is because that allows us, if I skip all the way to the bottom, that allows us to have a version of the location client that does actually touch the CL Location Manager APIs. This is the thing, this is the code we do not want to touch in our previews, and sometimes in our simulators, and certainly never our tests, but it is okay. This is the version of the client we want to use on the device when it's out deployed on the App Store. And instead, what we do want to use probably in a preview is something like a mocked version, something that just fakes where it is. And I believe this is the coordinates for LA. And so if I run this preview and we provide this mock location client, which just pretends that we have given authorization and that when you request it, we're in LA, I run this and I hit this button and we get recentered to LA. This is LA. All right, so we have a much more functional preview here because we took back control over that dependency. And I think even though now that the preview does allow us to get access to location stuff more so in the Xcode 15 than Xcode 14, I still think this client is going to be important because you still have no way of emulating the idea of the location manager failing. I don't know what I have to do to my computer to get it to start failing to get location, yet I could easily provide a location client that fails when I ask it for location. And then I would be able to confirm that, oh, this alert shows up, and when I tap on something in that alert, something happens. I get to explore more of my feature in the preview. So I'm glad Xcode 15 is doing more in the preview, but I still feel like we're going to want these to control these dependencies regardless. And then I'm going to skip the contacts one because it's basically the same. And so where we're at now is that we have controlled the dependencies, the location client, the analytics client, and time. We've controlled them all and made our previews and our developer experience in these features much better. And so maybe we could just stop right there. However, it sounds better in theory than in practice, because unfortunately things are a lot more complicated when you get into the nitty-gritty. Because if this was all I talked about, and I ended the talk right now, and you went back home and started trying to control your dependencies, you would be significantly frustrated with the experience of controlling your dependencies. There's more we got to do, and unfortunately, it has to do with safety versus ergonomics in controlling dependencies. So safety is the idea that, well, let's back up a second. Oh, no, all right, yeah. So the first problem is safety. So we most likely do not want to pass dependencies explicitly in the initializers like I was showing a moment ago. That means if you had a complex application where you could navigate from feature A to B to C to D, and one day D all of a sudden needed a location manager, even though none of the other features did, you would have no choice but to seed that location manager through C to B to A. You just have no choice. Like the only way for D to get that explicit location manager is to pass it through every single layer. And that's a huge pain. And so you would be tempted to then provide a default so that if you created feature D and did not pass a location manager, you supply it the live version, the live location client. And that would be great because you wouldn't have to pass it everywhere. And when it runs on the device, it works exactly as you want. You just get the live version. Yet in previews, when you're previewing feature D, you get to provide the custom one, the mock version. So that sounds great in theory, but it is not safe whatsoever because then if you back up to feature C and you want to preview it, you have no way to pass in a location manager to D. Because location C, or feature C was like, I don't care about location managers. I don't want to deal with that. And so now you have no choice but to run a live location manager or an analytics client in feature D while you're previewing feature C. This is just not safe whatsoever. You will inevitably get back into the situation of accidentally tracking live analytics when you don't mean to, or a broken SwiftUI preview when you don't mean to. And the flip side also is the ergonomics, where if you do the thing that we are currently doing and you supply this, this is just not ergonomic whatsoever. You would never want to work in a code base that requires you to explicitly pass dependencies through every layer. Because in a complex application, you are going to have dozens, if not maybe hundreds of dependencies, and Leaf features will want very custom specific things. And you'll just have no choice but to sprinkle them throughout, and it's a complete nightmare. So, and this unfortunately is just a dichotomy between safety and ergonomics. You can provide default values to get something super ergonomic, but it's not safe, or you can require the dependencies, and that's safe, but it's not ergonomic. And this is the entire point of a quote-unquote dependency injection library. There is no other reason for a library than if you want something that is a little bit safer than providing explicits, or safer than providing defaults, and a little bit more ergonomic than providing no defaults. You want somewhere in between those two. And the whole point of the dependency injection library is to find its own trade-offs, its own pros and cons of where it wants to draw the line between safety and ergonomics. If you want full safety, you don't need a library, just do requirements. If you want full ergonomics, do defaults, and you don't need a library. But most of us want somewhere in between, all right? And it's unfortunately not really possible to do full safety and full ergonomics. It is just, in my opinion, a law of the universe that we cannot have both of these things, and so you gotta draw the line somewhere. And there's a couple of libraries out there. There's these 5, and there's a few more. These are what seem to be kind of the most contributed to in the past couple of years, and also Stephen and I work on one. But I am in no way suggesting you use our library or the previous libraries. That is not the point whatsoever. The point is to understand why we would want to control our dependencies, and then what can we do about it, and then you got to research these libraries and see what are the pros and cons, where are each of these libraries drawing the line between safety and ergonomics, and what resonates with you. Because in particular, Steve and I took a pretty hard stance on structured concurrency and structured programming for our library, and we put our dependencies in what's known as a task local. And that makes it completely impossible for us to do certain things that the other libraries do. But also at the same time, it makes it possible for us to do things that their libraries can't do. So it's just always trade-offs. Okay, so I believe oh, before that, I've got the demos now where I'm going to bring in our library to then show how we can fix all the dependency problems, but in a way that is somewhat safe, somewhat ergonomic. And what happens is you import dependencies, our library, and you use the @dependency property wrapper to say, I have a dependency on a clock. You don't provide a default. The default is not needed whatsoever. But by default, it will use the live continuous clock. However, what you can do is use this little with dependencies scoping function to say, in the context of this operation, I want to override the continuous clock to just be an immediate clock. And so it allows me to switch over to this preview, and now this is an immediate clock. So even though I didn't provide the default, I just kind of marked it there. I still get to choose between what I want, but I can also just completely leave it off. Like here, no mention of the dependency whatsoever, and it loads up in its kind of default execution environment. So that seems good. But then over in the location demo, and this is the location and analytics demo kind of squashed into one, I am expressing my dependence on an analytics client and a location client. But the interesting thing is at the moment of registering a dependency with the library so that I can use it in this fancy property wrapper way, I get to also say, I want to use this version of the dependency only in previews, and I want to use this version of the dependency only in tests, and then also I want to use this version of the dependency in the live environment, like in the App Store or on device. And so what that allows is me to go to previews. I'm running the preview over and over, but it's tracking skipped analytics. None of the analytics are actually going to the server, even though down in the preview, if I look at the preview right here, there's no mention of me overriding dependencies whatsoever. It kind of just came for free because at the moment of registering the dependency, registering the analytics client, I say for previews, I want to use the no-op analytics client. So I get the safety, I get a lot of safety completely for free. I never have to worry about actually tracking live analytics. If it's ever run in the context of a preview, no-op analytics will always be tracked. I never have to think about it. And so if a feature that previously didn't have analytics all of a sudden gets analytics, I don't have to remember to override that dependency. It just takes the preview value immediately. And then same for contacts. Okay. All right, so this is just the beginning. We've covered a ton of things, but there's a lot more to learn, of course. So I highly encourage you to start thinking about what are the dependencies in your project, how you might take control over them, and start investigating whether a library would be appropriate, or maybe you do want to go full-blown safety or full-blown ergonomics. That's up to you. But there's a lot of other topics out there to understand before you can really let this idea proliferate in your code base. And first of all, designing dependencies. I kind of just showed you what those interfaces look like, but there's a lot of thought that goes into how do you properly make an interface to slap in front of a dependency. And then overriding dependencies, there's the concept of being able to kind of spin up a feature in your application in a fully sandboxed environment, a custom execution environment. For example, what if you had an onboarding feature where you wanted to allow the user to actually play around with a significant part of your app, but in such a way that it never made a network request, never wrote to disk, because it's just an onboarding experience. You don't want to muddy up the disk with a little scratch work they're doing. How can you kind of carve out that execution environment to run that one feature in? That's really fun stuff. And then testing, I didn't actually show any tests with the library, but it's absolutely possible, and you should really think about testing. And then, so yeah, if you're interested, check this one out. Also check out all the others. And then, thank you. Sorry for that problem earlier, but I guess it's a good thing, actually.